Now that we have seen the law of large numbers in play in a continuous setting, it is now time to test our understanding. Now, we saw how the law of large numbers emerged by following the analysis for the binomial distribution. And it should not at all come as a surprise to you to come to the realization that the law of large numbers is going to work whether the setting is discrete or it's continuous. So, here is a problem for you to try. Start now with variables which are intrinsically arithmetic. In other words, they take integer values only. We're going to look at repeated independent trials, and now the continuum is replaced by a discrete set of possibilities, the integers. Suppose now that these variables have a common expectation, mu, and a variance sigma squared. Your task is to follow along with the analysis we have already accomplished for the continuous setting and recreate a law of large numbers in the arithmetic setting. So what will you need? Well, first off, densities are going to give way to mass functions. Instead of having a mass density spread across a continuum, we now have probability masses attached to each integer. So let's say we've got a mass function in our usual notation, P of k, denoting the probability that a generic chance outcome x takes the integer value k. K, of course, runs through all possible integers. The idea of expectation now will have to become a weighted sum, and naturally enough, the integral in the continuum segues into a sum in the discrete domain. And of course, we're going to look at a weighted sum of values. This is the natural generalization of the idea of an arithmetic average, value weighted according to chance. And finally, we're going to need an idea of an expected squared deviation from the mean, in other words, the variance. And the variance again will have a very similar expression with the natural replacement of integrals by sums, densities by mass functions. So, have at it. And when you're done, let's conclude with a sliver. Now, what you've discovered really is that we have a law of large numbers in the continuous setting and in the discrete setting. And so here's a slogan. The law of large numbers is going to come into play anytime we have repeated independent trials and we form a sum of these variables. These variables should have a common expectation and a common variance. And in general settings, we will take the ideas of center of mass and the idea of a moment of inertia and extend it with suitable linear operations. And so, at the high level, the story is, whenever we have an expectation and a variance, and we have repeated independent trials, we're going to expect to see a law of large numbers emerge.